We get to the hydroponic part of the discussion on Thursday. I thought maybe we'd start with that today. I do a little basic introduction or discussion of the handouts I gave on Thursday. And then I don't have a lot of hydroponics going right at the moment, but some of the UH student projects from last semester, the greenhouse over here still has some plants that are intact, so I thought we could use them as kind of an example. They have a couple good systems that are a good example of what you can do, and then a few of them that things you may not want to copy exactly, but maybe you can modify. That's one of the cool things about students, working with the students, is if you let them, people do their creativity, sometimes they come up with really good ideas and things like that, so there's some kind of interesting things. What we're mainly going to be discussing today is the really simplified introductory way of getting into hydroponics, and it's a non-circulating plants floating in water. And this kind of method has been used actually for a long time. If you look at in Mexico, they have these floating, they call them chiampas, and they're actually in the edges of lakes and things like that. They built these floating rafts, and they grew plants on top of these floating rafts. And it's probably one of the earlier examples of kind of like hydroponic culture, things like that. And they actually had a very sophisticated set of channels and things like that, and they were very productive. They're very productive systems, and they're actually even productive to this day. So mainly what we're concerned with is providing the right nutrients for the plant to thrive and grow. And there are a lot of different kinds of fertilizers. Magnesium sulfate, is anybody familiar with that? Magnesium sulfate, have you ever heard of that? How about Epsom salt?
Yeah.
Yeah, it's the same thing. So maybe if you've soaked your feet in the past or something like that in Epsom salt, it's actually the magnesium and sulfur that's within this is actually, those are plants, important plant nutrients. So we use this chemical, and then we use something called calcium nitrate. And there are other forms of calcium nitrate, and what we buy is we buy the one that is soluble or solution grade, they call it. And so mainly this is, if you can, calcium is another important plant nutrient, and then nitrate are also, and nitrate is, so it provides the nitrogen, it helps keep the plants green and vigorous and things like that. And then the final one is we buy a fertilizer, and what I like to use for lettuce and what's recommended by CTAR is 8-15-36 hydroponic, like a hydroponic formulation. And this is really good because it also contains all the minor nutrients as well. So all of those trace minerals and things like that are in this package. And so you can get 2.5 pounds of this for like $10. So each of these 5-pound bags, this was like $3. This is $3.75. So for about $20, you can have a lot of fertilizer that will last you a long time. Because in the bucket I handed out last week, you'll probably use a teaspoon of this, a teaspoon of calcium nitrate, and just a pinch or so of this magnesium sulfate. So when you think about it, this makes a whole lot of solution for growing plants. There are also other products. If you go to Toyota, yeah, thank you, Toyota. They have a lot of different kinds of hydroponic solutions, and they have some that are complete. So what you want to look on the label is if it has all of those minor nutrients and things like that. And so this is something, they sell things that are, complete in as one unit, so you don't have to use 3 different products. The downside with that is sometimes the reason that we can't have this with the calcium nitrate and magnesium all together is because oftentimes the nitrate will begin to interact with some of the other chemicals and it actually becomes insoluble. And they call that locking out or locking up. And so when that happens, then the plant doesn't have access to it because plant roots take up things that are dissolved or in a solution. I like the Ohana greenhouse and Garden Exchange and places like that. They have a lot of different kinds of products. They have products with really funky, cool labels, but oftentimes you're paying for the picture on the front, and what you're getting isn't really a great deal for your investment, for your dollars. Lewis Street now, they're on Honolulu Street, just past where the food basket is moved to. Is it the Cheetah warehouse or something like that? Anyway, I can get you the address or whatever, but they have a lot of really good gardening stuff and they're pretty reasonable and you don't have to be a member to be there. See different types of elements, a combination of elements from the soil, and so that's why it's a concern to grow things in contaminated soils or things like that because the plants can actually take them up. But these are the things that we know are necessary. Without these 16 ingredients, the plant won't be able to complete its life cycle or something like that. And it would be good to mix with growing things in the ground, vegetables in the ground, things like that. We're just starting to experiment with using organic products, organic fertilizers that you buy, and growing in that. Sometimes organic is a little bit more difficult. Yeah, so compost teas would work. When you get into like growing with compost teas and making your own mixes, then you have to be much more cognizant of plant symptoms and what they're signaling you, like, oh, it's lacking magnesium, or it's lacking phosphorus or something like that. So you have to be a little bit more attuned to what the plant is telling you by the way it's growing. So it's just kind of this is like the cake mix recipe that I'm telling you today. And how often do your Duncan brownies go bad when you make a mix? Not as often as if you're making something completely from scratch, right? So this is kind of what I guess kind of.
So that measurement that you just gave us, a teaspoon, and a pinch, what is that in per gallon? Or is
that would be in that container. And actually, I have some of those containers, and we'll do some tests later on today. Ideally, if you get into doing this. What you would like to invest in at some point would probably be, unless you're really precise with weighing and measuring and know to have a meter, and this is called an EC meter. And what this does is it measures the conductivity of the solution. And so if you have pure water, it doesn't conduct electricity very well, but if there's minerals or salts in it, it will be able to carry a minute charge. And this device can test that, or it can measure that. And so I'm sure some of you guys have heard of ohms or Ohm's law. That talks about resistance. Well, this measures in mhos, which is just like kind of the reverse of that, or something like that. So it measures how well the solution can carry a charge, and all of the nutrients that we use when they're added to the solution will raise this level. And so what we're looking for is probably something, if you're growing lettuce, to be 1.2 to 1.4, they call it millimoles. It's not that important. You just would want to look on the gauge for where it says EC. This is a really nice one because it doesn't require calibration. It's pretty heavy duty. You can't break it very easily. It's totally submergible. You can drop it in your solution, your tank. It seems to be really cool lights that light up the stronger it is and stuff like that. So we'll do a couple tests today and get you the test. These are about $120, but it should last you years. And we've had it. I had a different meter, and that lasted for like 4 or 5 years with the pretty abusive conditions here with us and the students and things like that. So if you really get into hydroponics and you want to experiment around and you want to make your own, them is kind of a standalone. This would probably be put into a different kind of system. They actually have like a cover with a bigger pot. And this would be like great for growing peppers or something like that. And what you might want to do, you could either grow it as a system where you maintain the water level, or they actually have circulating systems that you could build to incorporate rows of these buckets or something. This I got from the Ohana greenhouse. The Ohana greenhouse really specializes in kind of higher end, more sophisticated growing systems and things like that. They cater to the people who don't really, budget isn't their biggest issue.
That's a good way to put it.
But that being said, it's really interesting how the hydroponic culture has changed the way people grow plants and approach growing plants and things like that. So there's been some interesting innovations that have come about and have become used by a greater audience. This is even a larger net pot. You could use this pathogens like root rots and things like that. This is a slightly larger one, again with that little